Well, let's continue. Just now we have finished at the T table and the properties of T distribution. Now we have know what's the meaning of T distribution and how to use T table. And the next one, we can use T distribution to solve some questions about hypothesis and estimation. So next one, we will learn how to use the one sample t-test to do hypothesis test and confidence interval estimation. So the first one, let's talk about one sample t-test for the mean of a normal distribution with unknown variance. So here we notice that actually this is the precondition for one sample t-test. We have mentioned that in z-test, the precondition is normal distribution and with known variance. And we find that here in one sample t-test is used for also a normal distribution, but this one is different with unknown variance or standard deviation. So that means sigma is not given. I think I have mentioned that in the last hour. We said that T, how can we get T distribution? T distribution is from Z distribution. And in the Z distribution, we said that sigma is given. But when sigma is not given, we need to use S to replace sigma, and then we get T distribution. So here, the precondition for t-test is sigma is not given. So if we find that there is no sigma in the question, we need to use T distribution for hypothesis test. So let's think about it. Here is a question. A study is devised to determine if the average cholesterol level of offspring of men who died of heart disease is evaluated above normal. Suppose the mean cholesterol level in children is 175. A group of 10 children whose fathers had died from heart disease were found to have a mean of 200 with the same standard deviation 50. Test the hypothesis that the mean cholesterol level is different in this group with the general population. So let's think about the question first. The question is the last sentence. Test the hypothesis that the mean cholesterol level is different in this group with another one. So that means the purpose of this study is to compare the difference between two groups. So here we find that different, that is the key words for the question. So when we are talking about the difference between two groups, that means the question must be about hypothesis test. So now, with the help of the keywords, we already know we can use the method of hypothesis test. And we have already know two methods of hypothesis test. The first one is based on z distribution. We call it one sample z-test. And the second method is what we have learned this class, that is one sample t-test. And we notice that all of these methods are used for one sample. So, is that a question about one sample? Let's identify it. So here, we found that there are so many numbers in the question. For example, 175. That is the mean cholesterol level. So that means that is the mean, not the sample size. And what is the sample size in the question? It's here. A group of 10 children. So this is the sample size. This is the little n. N equals to 10. So can you find another number of sample size? No, you can't. You cannot find another sample size in this question, right? Okay, so we can find that there is only one sample size in this question. And the sample size is 10. So we can use one sample test. But till now, we don't know which method we can use, z-test or t-test. Okay, next one. How can we know if we can use t-test or z-test? We need the precondition, right? We have mentioned that the difference between t-test and z-test is their preconditions. And the most important preconditions is the variance or standard deviation. So if the variance, namely sigma square or sigma, is given, we can use z-test. But when sigma is not given, we can only use t-test. Okay, so now let's find what is the sigma in this question. Or I can say, is there any number of sigma is given in this question? We find that here, standard deviation, right? Standard deviation, and the number of standard deviation is 50. But here's my question. This number 50, is that the number of sigma? Well, actually, this number is not the number of sigma. Why? Let's think about it. What's the meaning of sigma? That is standard deviation, but that is standard deviation of a population, not a sample, right? So sigma is the deviation of a population. So here, let's think about this number. This is the standard deviation, but is this number a standard deviation of a sample or a population? So let's read this sentence. A group of 10 children has a mean with the sample standard deviation. So we find that this number is calculated with the data of 10 children. And we said that 10 is a sample size. So that means 10 children is a sample. So here, this is the standard deviation of the sample, not a population. So that is not sigma. That should be S, right? So here S equals to 50. So there is no sigma. So that means sigma is not given in the question. So we cannot use z-test. So we can only use one sample t-test. Okay, let's review what we have known. The first one, there is only one sample size in the question. So we decide to use the method of one sample. And the next one, we find that sigma is not given. So we need to use t-test. So finally, we choose the method of one sample t-test. Okay, that's right. Let's go back to this slide. Let's think about the meaning of the numbers. This is the mean, but let's think about the number is the mean of a sample or a population. Let's read this sentence. Suppose the mean cholesterol level in children is 175. That means this is the mean for the children, not just for the 10 children, but for all of the children, right? So this is the population mean. So that is mu0. Mu0 equals to 175. And this number, we have mentioned that this is the sample size. This is the 50, that is the S, right? Sample standard deviation. And the last number, 200. This is a mean, right? But we have already known that this is the mean for the sample. So that is the sample mean. So that is the X bar. Okay, now we have already know all the numbers, all the given informations in this question. And next one, we can finish the exercise. And this is a question about hypothesis test. And we said that the procedure for hypothesis test have the same steps. So that is step 1, 2, and 3. So we just follow the same procedure and we can get the answer. So this is what we have known from the question. And in the procedure of hypothesis test, the first step is to establish the statement of hypothesis. The null hypothesis is there is no difference, right? So we can use mu equals to mu0 to represent the null hypothesis. And alternative hypothesis is in opposite against H0. So HA is mu is not equal to mu0. And don't forget to set the number or to set the level of significance. So that is alpha, and we choose the most commonly used number 0.05 as the significant level. This is step 1 and step 2. In step 2, we need to calculate the test statistic. And this method is t-test, so we need to calculate the t value. But the first thing, when we are talking about the t value, that means the number should follow t distribution. And we know that the shape of the distribution is based on a special number that is nu. So the first one, we need to figure out the number of nu. Nu, namely df, equals to n minus 1. In this question, we find that the sample size equals to 10. So nu equals to 9. Yes. Okay. So next one. According to the formula for t distribution, we can figure out the t number. And you need to remember this formula for t value. That is similar with the formula for z value, and the formula of z value is what you need to remember too. Okay, so here we need x bar, s, n, and mu to get the t number, and all of the numbers are given in the question. We have already know all of these numbers, but there is no mu in the question. We have mentioned that last class. In the first step, in the null hypothesis, we suppose mu is equal to mu0, and we try to test if the h0 is true or not. So we firstly suppose mu is really equal to mu0. So here, actually we use mu0 to replace this mu, and we just put the number of mu0 into the formula. Finally, we get the number of t. Here is something special. You need to notice that. Sometimes we will find that after the calculation, we get a t value which is a negative number. But in our table A2, there is no any number of negative number. So if you really get a negative number, you need to change this number into its absolute value when you are checking the t value in the t table. Okay, so this is the second step. And next one is step 3. We need to make a decision. Reject h0 or not reject h0. So how can we do that? We need to use this t value, that is 1.58. Okay, so at this time we need to use table A2. We need to find a special t value, or we can find the corresponding probability of 1.58 in table A2. So let's go to the textbook. Okay, so we have already know this is table A2, and the new is 9, right? And we find that the number of t is 1.58. So let's find it. There is no 1.58, right? Because we said that this is not the whole table for t distribution, right? In this table, the most commonly used probability and its corresponding t value are listed. Not all the t values. So here we cannot find this number, but we find another special thing. The number is 1.58. That is what we get from the data of the question. And we find that this number is between these two numbers, right? 1.383 and 1.833, right? Okay, so this number is between these two numbers. So that means its corresponding probability is between these two numbers too, right? And this number, 1.383, its corresponding probability is here, two-sided, because we said that in this class we won't talk about the probability of one-sided, so we will just use two-sided. So its corresponding probability is 0.2. And next number, 1.833, its corresponding probability is 0.1. And 1 0.58 is between these two numbers, so its corresponding probability is between these two numbers too. These two probabilities too, right? So P, we'll find that its corresponding probability is bigger than 0.1 but less than 0.2, right? Okay, so now my question is, in hypothesis test, we need to compare P with alpha, and we already set the number of alpha as 0.05. So P and alpha, which one is bigger? Yes, of course, P is bigger. So P is bigger than alpha. Why? Because we have proved that the P is between 0.1 and 0.2. So P is bigger than 0.1. It must be bigger than 0.05, right? Okay, so now we have known P is bigger than alpha. So can we reject H0? No, we can't, because when P is bigger than alpha, we cannot reject H0. Yes? Okay, we cannot reject H0 because we have already known P is bigger than alpha. Okay, so that's actually that is one method for you to identify if the corresponding probability, the P, is bigger or less than alpha. But there is another method, there is another way to find the conclusion, to find the answer. That is what they used in our textbook. So how can we know if P is bigger than or less than alpha? This is the second way. So here we find that this is the t value we calculated with the data which is given in the question, and this is another t value. So what's the meaning of this one? I call it the standard t value. The standard t value. So what's the meaning of that? Let's think about it. Now this is the t 1.58, what we have calculated with the data which are given in the question, and we want to know its corresponding probability, that is the capital P. But now P is unknown, and we want to compare this P with another number, that is alpha, and alpha is 0.05. We want to know if P is bigger than or less than or equal to alpha, right? But if P is unknown, we cannot do the comparisons, right? So we can find another way. That is, we need a standard t value. So this is standard t value. So here, this t value, how can we get that? Actually, if we know the new and two-sided alpha, two-sided probability, we can find the standard t value in table A2, right? Here we have already known new is 9 and alpha is 0.05, right? So we can use these two numbers. We can use these two numbers. Oh, I make a mistake. Let's clean it. Okay, we can use these two numbers to find a special t-value in table A2. That is the standard t-value. So can we do that? Of course, we can do that, right? So let's find it. Let's go back to the table A2. Let's turn to the page of table A2. It's here. Okay. So now new is 9 and two-sided alpha is 0.05. So let's find the standard t-value. The t-value is 2.262. So what's the meaning of that? This is the standard t-value, right? So that means when t half 0.05 equals 2.262, its corresponding probability equals to 0, namely alpha 0.05, right? And this is what we calculated with the data given in the question. And we want to know its corresponding probability, right? So now we change the question into the comparison of these two t-values, not the comparison of these two probabilities, right? Now we can compare these two numbers of t. So let's think about it. Now this one, 1.58, is less than 2.262. So what's the meaning of that? We needed help of the curve. This is the t distribution, and all of these two numbers are positive. So this should be located in the right part of the curve, right? This is 1.58. This is the 2.262. And we said that the corresponding probability is outside the number, right? So we find that, let's change another color. We find that the area of 2.262 is this right part to the right side, right? But the probability of 1.58 is also to the right side, but its area is cover the area of 2.262. So that means the corresponding probability of 1.58 must be bigger than alpha, right? So we find that it's the same with the first way we used in table A2, right? The first way is to we find two numbers, that is 1.38 and 1.83, right? And this number locates in between these two values. So its corresponding probability should be between the probability of that two numbers too. So we prove that the p is bigger than 0.05. And here we have the second way. That is, the first one, we use alpha and nu to find a standard t-value in table A2. And next one, we compare the t-value what we calculated with the data given in the question with the standard t-value. And if we find that the t-value is less than the standard t-value, that means p is bigger than. The reason is here in the picture, in the curve, right? Okay, so here, that means if we find that the t-value which we calculated is bigger than the standard t-value, that means its corresponding probability will be covered by alpha, right? So that means its corresponding probability, the capital P, is less than alpha. So we found that these two symbols, they are in opposite. If T is bigger than, its corresponding P must be less than. If T is less than, its corresponding P must be bigger than. Okay, so here is another thing you need to notice, that because all the t-values are positive numbers which are listed in our textbook, so if you get, after the calculation, you get a negative number for the t-value, you need to change it into its absolute value. So we do need to compare this negative number with the standard value. You need to change it into the absolute value, and then you can compare the two numbers of t. Okay. Okay, let's go back to this slide. Now we have two ways to prove p is bigger than 0.05, is bigger than alpha, and we can know the conclusion. The conclusion should be not reject H0. So that means the mean cholesterol level of the 10 children does not differ significantly from the population at the 0.05 of significance. So that is the answer to the question. Okay, so this is the method of hypothesis test based on one sample t-test. And next one, that is the same with what happened in z-test. Just now we use the test for hypothesis test, and the next one we can use the t-test to estimate the confidence intervals. Okay, so here is the determination of a 1 minus alpha confidence interval for the mean of a normal distribution with unknown variance. So we can find that this method for confidence interval has the same precondition with the with the hypothesis test based on t distribution. The precondition is there is no sigma. So until now we have talked about two methods used for confidence interval. The first one is z-test, and the second one is t-test, but their preconditions are different. Z-test is used for sigma is known, and the t-test is used when sigma is not known. Okay, so here, so it's the same with what happened in z-test. Now I will explain how can we get the formula. It's similar with the z distribution. So do you remember the z-test for confidence interval. We said that the distribution curve is symmetric about z equals to 0, right? And we said that we have two numbers of z. The first one is a negative number, negative z, and this is positive z. And between these two numbers, the probability is 1 minus alpha, right? And we change these two numbers of z into its corresponding x, or to change it into corresponding x bar. So we will find that this number should be x bar minus z alpha times sigma over square root n, and this number should be plus square root n. So between these two numbers is the range of the population mean. So we call it 1 minus alpha confidence interval. So that is the confidence interval formula. And how about the t-test confidence interval? It's based on t distribution, and we said that z distribution is used for sigma is used when sigma is given, but in t-test sigma is not given. We use s to replace sigma. So here we just replace all the sigma with s. And next one, because the data follows a t distribution, not a z distribution. So here this is not z alpha, but t. Yes, t nu of alpha. So that is the formula for t-test confidence interval. Okay, so let's go back to this slide. This is the confidence interval formula, and we have explained how can we get this formula. Mu is between these two numbers. The first one is x bar minus t times s over square root n, and x bar plus t times s over square root n. So we also call it 1 minus alpha confidence interval. So if we need to calculate the 95% confidence interval, we need to find out the t value from the table A2. And we also need two numbers. The first one is nu, n minus 1, and the second one is half alpha. And here alpha, because of the probability of confidence interval equals to 95%, so that means alpha equals to 0.05. So that means two-sided, and alpha equals to 0.05, right? Okay, so let's do it. Let's try to find the t value from the table A2. So for example, here we need to compute a 95% confidence interval for mu using the data in example of 5.7. So 5.7 here, n equals to 10, s equals to 50, and x bar is 200. So the first one we need to find the df, that is 9, right? And two-sided alpha equals to 0.05 is corresponding t is 2.262. It's the same with the standard t value we used in hypothesis test. Okay, so here we just put all the numbers into the formula. This is x bar, this is t, s, the little n, and this is plus, right? So we just figure it out. The population mean is between 164 and 235. Okay, so that is the method for confidence interval based on t-test. In today's class, we have talked about the method based on t-distribution, and we have explained the properties of t-distribution, and we have explained how can we get t-distribution. And you need to remember the formula for t, and we have learned the method of hypothesis test based on t and confidence interval estimation based on t distribution. You need to remember the formulas for all of these two methods. Okay, next one. Let's do some exercise. This is the exercise 1. In a study of males' serum cholesterol, 16 individuals are randomly drawn and the mean is 3.64, while standard deviation is 1.2. Calculate the 95% confidence interval of the mean. Okay, so let's think about it. Is this a question about hypothesis test? Well, it's not, right? Because we find that the question is to calculate the confidence interval, right? It's not to identify if there is any difference, right? So we don't find the keywords of different or difference. It's just about the confidence interval. So we know that we need to find the x bar as the little n, and we need to find the t value from the table A2. So here, let's analyze the informations which are given in the question. So this one, 16 individuals. That means this is the sample size. N equals to 16, right? And this is mean, but we find that this is the mean for the 16 individuals. So that means this is x bar. So x bar equals to 3.64. And standard deviation. Standard deviation is 1.2. But here is my question. Is this standard deviation sigma or S? Yes, this is S. This is not sigma, right? Because we find that this is the standard deviation for 16 individuals. So that is not sigma, because sigma is standard deviation for the population, for all of the people. So this is S. Okay, so do you remember the formula of confidence interval based on t-test? That is mu bigger than x bar minus t times s over square root n, and less than x bar plus t times s over square root n, right? So we just need to find t and put all the numbers into the formula. So how can we get t? We know that t, if we want to find t, we need two numbers, that is nu and two-sided alpha. And here, in this question, n is 16, so nu is 15. And two-sided, the probability, the alpha is 0.05, because the probability of confidence interval is 95%, right? Okay, so let's go to the textbook. here, the first one is to find new 15, right? And two-sided 0.05 is here in this column, and let's find the t value. That is 2.131. Okay, so that is the t value. So we just put all the numbers into the formula, and then we can get the result. Okay, so here, this is the t value that we can get from the table. That is 2.131, and we put all the numbers into the formula. Finally, we find that the 95% confidence interval is between 3.001 and 4.279. So that is the 95% confidence interval for this question. Okay. Let's try another one. A large scale survey reported that the mean of poses for healthy males is 72. A physician randomly selected 25 healthy males in a mountainous area and measured their poses, resulting in a sample mean of 75.2 and a standard deviation of 6.5. Can one conclude that the mean of poses for healthy males in the mountainous area is different with that in the general population? So let's find the keywords. Do you notice that these keywords different? So that means this question is not about confidence interval. This question is about hypothesis test, yes. So here, let's find the sample size. We find that the first number, 72. So this is the mean, right? The mean of poses. And we find that this mean is from all the healthy males. So this is the mu0. Mu0 is 72. And the next one, the second number is 25. Oh, this is the number of healthy males in a mountainous area. And this is a small group which is randomly joined by a physician. So this is the little n. This is the sample size. Can you find another number of sample size in this question? No, you can't. So there is only one sample. So that is one sample test, one sample hypothesis test. So next one, let's analyze if we can use z-test or t-test. So the key point is to find sigma. So this is the third number, 75.2. So that is a sample mean, right? X bar. Okay, so the last number is a standard deviation of 6.5. So is that a sigma? No, because we can find that this number is calculated with the data of 25 miles. So this is not sigma, this is S, right? Okay, so sigma is not given in this question. So can we use the test? No, we can't. We need to use t-test. Okay, so this is the procedure for the hypothesis test of t-test. The first step is to establish the statement of the hypothesis. H0 is mu equals to mu 0, and HA is mu is not equal to mu 0. Alpha equals to 0.05. So we can find that in all the hypothesis test, of one sample test, no matter z-test or t-test, they have the same step 1. And in step 2, the first one, let's calculate the df, the nu equals to n minus 1. that is 24 in this question. And next one, according to the formula, let's try to figure out the t value. We put all the numbers into the formula and we can get the t is 2.462. And next one, let's find it. Find the standard t value from table A2. We find that the standard t value is 2.064. We find that this number, this t value, what we calculated with the data given in the question, is bigger than this one. So that means its corresponding p is less than alpha. So p is less than alpha, we need to reject H0. So the conclusion is there is significantly difference between the two groups. Okay, so that's all for chapter 5. That's all for today's class. Next class, we will talk about chapter 6, two samples, statistical inference. Okay, so that's all for today's class.